Good morning, ladies and gentlemen. My name is Alessandro Bettin. I'm a civil engineer and I work for SGI. SGI is a private company settled in Italy with around 100 employees. And during the last year, we have been awarded in several European projects. And today I'm here to present one of the latest experiences. The project is called Life Salt, and is co-financed by the European Community in the program LIFE. There is an important co-financing from the Ministry of Environment and Sea, the Italian Ministry of Environment and Sea. There are several partners, some institutional like Regione Marche, Provincia di Ancona, a water company that is the coordinator of the project, is called Multiservizi in Ancona. Then SGI and SPS are technical partner, and Centro Euro-Mediterraneo per I Cambiamenti Climatici that is responsible for the study related to the climate change. The main objective of the project is to set up a standard methodology for the study of the degradation trend in the coastal aquifer. And we intend for degradation trend, the degradation in the water table and the salt intrusion. The main project activities are data collection, modeling of the aquifer, of the river watershed, and calibration of the model, and then simulation scenario for the current situation and the future scenario considering climate change. The project takes place in the Esino River, that is in the center of Italy, in Ancona. The extension of the basin is around 1,200 square kilometers with a length of the river of 90 kilometers. The average discharge is 15 cubic meters per second. It's not a big river. But the first part of the river is torrential because there is an important slope, because the higher part is around 1,000 meters above the sea level. The alluvial aquifer of this watershed is around 135 square kilometers, and this is what we are going to study in this project. We have a not very important pumping rate from this watershed, around 6.8 million of cubic meters per year, and an average precipitation, historical, of around 840 millimeters per year. The problem is the degradation of wells. The possible problem that has been also experimented during the 60s is the degradation trend of some wells that are near the shoreline that are now used for water supply purposes when the main source is in the mountains not available. Just a few words. Multiservizi is the water company for water supply, uses an important source upstream in the water basin. There are a lot of water, but they have to guarantee the minimum flow in the river. So during the summer, when they have to guarantee the minimum flow in the river, they have to decrease the pumping from this source, and therefore they use some wells that are in the lower part of the basin. And some of these wells maybe can be interested in the future by salt intrusion. As far as the monitoring campaign regards, this was carried out during last year. We measured the continuous level in 3 points in the river, in 3 level meters. We calculated the velocity profile with some spot measurement of flow, both in this section and in other cross section, in order to evaluate the rate curve and to calibrate the flow. Then we made some spot flow measurement in the river in order to try to understand the exchange between the river and the aquifer, the recharge from the river and the aquifer and vice versa. Another set of campaign was carried out in the aquifer. So we measured in some wells, in some particular wells, the water level and the electric conductivity in order to understand any possible trend of salinity. Then we made a topographic survey of these wells in order to report this data in the model. This is an example of the electrical conductivity carried out in one well. We are about 2.5 kilometers from the sea. We don't have any problem here of salt intrusion because, as you can see, the level of conductivity is low. But in any case, we can experiment a wedge interface between 15 and 20 meters, a difference between, we move from 500 to 1,000 and 300 microsiemens And this is the map of the electrical conductivity in the watershed, in the aquifer. I would like to remark your attention here in one event that happened 1-2 March this year. It was a very big event with some peak flow in the Marche region of around 200 millimeter in 1.5 day, 1 day around. And here in the basin, in our basin, we had 68 millimeter as an average. And during this event, we measure an increasing water table of up to 1 meter. So this is an important information that show that the aquifer is responding very fast to the rain event, to important rain event. Let's see the integrated modeling chain that has been applied to this watershed. The first stage was the building and calibration of the rainfall runoff model of the river using HMS from the US Corps of Engineers, the American US Corps of Engineers. Then the output from this model has been used as input for the hydrodynamic model of the riverbed using a RAS model from the US Corps of Engineers again to simulate the river hydraulic and above all to extract the water level. And then finally, we built and calibrated the model of the aquifer using the FIFlow. It's a three-dimensional finite element analysis software for the modeling of groundwater. These slides show the first stage of the modeling with the calibration of the rainfall runoff for the river. We use some extreme event from 2010 and even to verify the model some events from the 80s and the 70s. You can see here some correlation between measurements and simulation. As I told you before, the output from the model, from the hydrological model, has been used as input in the upstream cross-section of the river, in the closer section of the river, in order to reproduce the dynamic and the water level. And this is a cross-section near the river mouth. And then, starting speaking about the aquifer model, the most important part to build an aquifer model is to understand the stratigraphy of the ground. And we acquired some studies from, of course, preliminary study already carried out. We didn't make any analysis of stratigraphy. And we load 120 points that you can see here with the correct stratigraphy. And then from this stage, we developed the full model in FIFlow. So starting from the point with the non-stratigraphy, we use a DTM, a digital terrain model with 500 meter resolution. We overlap the two information and created estimated stratigraphy for all the slices of the model, for all the points of the model. Before running the simulation, we acquired all the boundary conditions for this model. The boundary conditions are the hydraulic head upstream and downstream. Downstream we have the sea, the Adriatic Sea, the river dynamic water level, the rainfall, the salinity, and the pumping rate from well. As far as the rainfall regards, the first simulation stage was considering 7 years of simulation because unfortunately we had no more data. So from 2003 and to 2010, this is called the current situation. And this is the analysis of the 3 main rain gauges that has been used. This is the total rain, and the graph shows the net rain that entered the system after calculation of the evapotranspiration. This is the simulation of the flow in the river, and this flow has been used to take the variation of the water level and to integrate the water level in the aquifer model to simulate the exchange between the river and the aquifer. Here we are looking the pumping rate. Even for the pumping rate, it was very difficult to acquire information. And this graph here is the main pumping flow that is extracted in this part, in the downstream part from the water supply company to feed during the summer, to complete the feeding of the population when it is needed, because they can't pump from the main sources. And you can see there is a decrease in the pumping rate. It means that during the last year, after 2007, we had a good year of good rain. They were rainy years, even in the summer, so there was not the need to integrate the pumping. This is the result of the calibration of the model. The red points are experiments, are a measurement point during the year. We have two points per year in 2 wells. And the line is the continuous simulation of the model. And here we see also the rain event. And you can see that the aquifer responds very fast to the rainy period. And the calibration is quite good. And we don't see any trend. We don't see any increasing or decreasing trend in the water table. This is for the past period. As far as the salt intrusion regarded, it is one of the most important parts of this study. We see from the first simulation, the current scenario, that the salt intrusion is limited to some part of territory near the shoreline. We can say 50, 60 meters. You see the concentration in green is around 20,000 milligram per liter. We know that the sea is about 35 milligram. 35, 38 milligram per liter of salinity. But we want to see if in the future we can have any problem in this well that is the nearer to the shoreline, and possibly also in this one. To do that, we have to make a forecast, a simulation for the next years, and this is the rain forecast till 2100. Of course, we have seen, everybody knows that the rain forecast is not very reliable as the temperature, we can say. But CMCC made the simulation of climate change using the IPCC scenario, using their model with 7 kilometers of range. And this is the output of the rain. You can see a slight decreasing trend. And together with the increasing trend of the temperature, we are going to expect probably a decrease in recharge, because the evapotranspiration is going to increase. So, going rapidly to the conclusion, the aquifer is not affected by overexploitation, because the pumping rate is not very important. We don't have any decreasing in the water table. The current salt intrusion interests only the shoreline, 50 to 100 meters. And the next step will be the future forecast of rain and temperature that has already been done as a level of time series for the period 2011-2030. Probably we'll extend the simulation to 2050 to have a longer period. Will be used for climate change scenario simulation. And what we are going to investigate is the projected maximum exploitation trend that can be used for this aquifer, considering, for example, some worst scenario, considering several dry years, and the evolution of salt intrusion, with particular interest to these wells that are near the shoreline. That's all for the presentation. I would like to thank you for your attention. And if you need more information, you can find at the website lifesalt.it. Thank you.